Hello my Amiga friends out there. So I'm making this video response because I found two video clips posted by a YouTuber who is having a problem with his Amiga 1200, and I think that I have a pretty good idea of what might be causing that problem. So I'm making this video in order to provide this person with a little piece of advice so that hopefully he will be able to fix his Amiga. Now I'm going to post links to his videos in the description for this video, so you can check out his videos if you feel like it. But let me just give you a quick summary of what kind of problem he is experiencing with his Amiga 1200. So he is in Workbench, and he's trying to low-level format a disk. So he's putting a disk in his internal disk drive like this, and the icon for that disk pops up on screen. He's highlighting the icon, he's choosing format in the menu, and he's then starting a low-level format of that disk. And the window that, the window with the progress bar, that window pops up on screen just as it should, and we can see the progress bar moving from left to right just as it ought to, so nothing strange, and it appears as the disk is being formatted without any problems. Then when the progress bar reaches 100%, then of course the new window pops up saying initializing disk, just as always, and then again the icon for the disk pops up on screen, and that is of course perfectly normal, but the icon is the same and the label for the disk is the same, and the content on the disk is also still there, so the disk can still be opened and the files can still be read. So it's the same content on the disk as before the format was being executed. So it appears it's just as the format never took place in the first hand. So then he tried to connect an external disk drive, and he tried to format a disk there, and he got the exact same problem. So he wrote in the description for one of his videos that he thought that there might be something wrong with the floppy controller, and I think that's a pretty good conclusion, and I perfectly agree with that. However, exactly what is wrong with the floppy controller, or what can be wrong on the motherboard, exactly what can be causing this kind of symptom? So in this video I will give you my analysis of this problem, and well, unfortunately I cannot fix the motherboard for him, obviously, because I don't have his motherboard here, but I will provide you with my analysis and give you an idea of what might be causing this problem, and also give you a few hints on how to fix this problem. Okay, so to start with, I would just like to mention that when talking about an Amiga, the so-called floppy controller is actually quite an abstract term in a sense, because the floppy functions are not controlled only by one chip, but they are actually controlled by several of the custom chips on the motherboard. For example, here we have the event CIA, and that is responsible for stepping the heads, among other things, and Paula is the one that is receiving the incoming data, and it's also putting out data to the floppy disk drive as a write operation is being performed, and Gail is responsible for the motor on signal to DFO, if I'm not mistaken, and there might be some other custom chip also somewhere on the board that is responsible for something else. I'm not completely sure, I have to check the schematic for that, but in any case, what I just want to point out here is that there is no specific floppy controller on the motherboard, but I will still use the expression floppy controller from now on in this video, in order to refer to all the custom chips that are involved with the floppy functions. Okay, now let me give you my idea of what's going on with the Amiga. So here I have drawn a really rough diagram, and this is not an exact representation of how things actually are connected on the motherboard, it's just a model, okay? So here's the floppy controller and here's DFO, and several signals are going between the floppy controller and DFO, and several signals are also, of course, going between the floppy controller and DF1. But this is not how things are actually connected on the motherboard. In reality, it looks more like this. So DFO, DF1, and also DF2 and DF3 are all sharing most of the signal lines going to the floppy controller. Now let's imagine a situation. Let's imagine that there's a break in one of the signal traces going to DFO, like this. So what will happen? Well, obviously this signal will not reach DFO, and DFO will not be working as it should. But how about DF1 in this case? Well, the signal will still reach DF1, so DF1 will not be affected. Now, let me restore this connection like this, and let's imagine another situation. Let's imagine that instead the break is here. Now what will happen? Well, this signal will not reach very far, so it will not reach DFO, and neither will it reach DF1. So in this case, both DFO and DF1 will be having the same problem. And this is exactly what I think has happened to your Amiga. Now, which one of these signals is the signal that is causing this problem? Well, in order to find that out, let's take a look at the pinout for the floppy controller interface. And if we take a look at the real schematic, we can see that what I just explained is actually what's going on. Here you can see the internal floppy connector, and we have the external one here. And we can see that these two floppy connectors are sharing the same lines. Okay, so now I'm at this website called pinouts.ru. It's really a wonderful site for checking pinouts, and I'm sure many of you have heard about it before. Now I'm taking a look at the pinout for the SugarArt interface here. There is also another pinout for the PC-based floppy interface, but that is slightly different compared to the SugarArt interface one. And I'm interested in the SugarArt interface here because that is what the Amiga is using. So if we take a look at the pinout here, we can see that there are only two signals responsible for the write operation, and that would be the write data here, and that contains the actual data that is being written to the disk. And then we have floppy write enable or write gate, and that is gating the write data signal. So I think that the problem you're having with your Amiga 1200 might have something to do with one of these two signals. So let's get back to the workbench and do a few more experiments. Okay, so here I am with my Amiga 1200 motherboard, which is in fully working condition, and I have it hooked up to an internal disk drive here, which I have flipped upside down, as you can see. Now, as I mentioned, there are two signals we're interested in, and one of them would be this one, right on pin 22. And there we have the incoming serial data to the floppy disk drive. So when the disk drive is performing a write operation, a lot of serial data is coming into this pin here. And the other signal we're interested in is this one on pin 24, and that is the gate signal. And I will show you how these two signals look like on an oscilloscope. Now obviously I have this ribbon cable connected to the floppy disk drive, but I also have my oscilloscope probe connected to the ribbon cable, and that oscilloscope probe is connected to channel 1 on the oscilloscope. So let's take a look at the signals right at pin 22 and pin 24. So now I have a disk in the drive and I'm pretty much ready to start formatting. So let me just click on format here, like that, and now the drive is spinning the disk and the disk is being formatted. So let's take a look at the oscilloscope here, and this is how it looks like. This is all the serial data that is coming into the floppy disk drive right now. And I can also change the time base if I feel like it, like that. But anyway, this is how it looks like. It's just a lot of serial data coming into the floppy disk drive. So that was the serial data. Now let's take a look at the other signal we're interested in, the gate signal. But before that, let me just explain something quickly here. So imagine that this is a channel, and through this channel a lot of water is flowing. If I put a gate there, then that will stop the water flow, right? No water can reach the other side of the gate. In the same way, the data flow, or the serial data that is flowing through this channel, can be gated. It can be stopped. And this gate signal can be in two states, either closed or open. So if it's like this, then the serial data can go through the channel. If it's like this, then that will stop the serial data. So let's take a look at how the gate signal looks like. And again, I'm ready to start formatting. So let me click on that. Okay, and the disk is spinning. And let's take a look at the oscilloscope. Here we have the gate signal. Now, we can see two lines. And that is because down here we have around 0 volts and I don't know, maybe 4 or 5 volts up here, around 4 I think. So when the voltage is down here, then the gate is open and the serial data can go through. And when it's up here, the gate is closed. Now we can even take a look at both the serial data and the gate at the same time. Let's look. So let's do that. Okay. So here's the serial data. Here's the gate. We can see that every time serial data is coming into the floppy disk drive, then the gate is opening that channel. So the gate is open when this line is down here, and it's closed when it's up here. So we can see that at the very same time as this data is coming in here, then the gate is opened. Now it's about to finalize this format here. Now it stopped formatting and both signals went up to their idle state. So the problem that this person is experiencing with his Amiga is most likely due to a problem with either the incoming serial data, pin 22, or a problem with the gate signal, pin 24. Now, which one of those two signals might be causing this problem? So, let's try that out. Here, I have cut the signal for the serial data, the incoming serial data. Now, let's format a disk and see what happens. Alright, so what I have done now is to put extras on this disk, Workbench extras. So let's try to format this guy and see what happens. And we got our disk icon there on screen. Now remember, this wire that I have cut, that is the incoming serial data. So that means that I can still read the disk without any problems, because the read data line is not cut. That works fine, so I can open Windows here and read the data on the disk. No problems whatsoever. Now let's try to format this disk. Like that. Format. And let's see what happens. Okay. Listen to this sound. Now, this disk drive is not happy because it's not receiving any serial data. So it cannot format the disk, obviously. But this doesn't look like the same kind of problem that the person is having with his Amiga 1200. So I don't think that he is having a problem with the incoming serial data to the floppy disk drive. So yeah, but I will just, for the sake of it, I will let this progress bar go to 100% and see what happens. But this takes forever, so I will stop the video here and I will get back to you guys when it's almost done. Can you hear that sound? That is the sound of the stepper motor going back to track 0. and then back to the track it's trying to format. And why is it doing that? Well, it's trying to use the track 0 detector in order to find out where it is. Because the track 0 detector is the only way for the floppy controller to know where the heads are. So when it fails to format a track, then it wants to find out, are the heads really at the right track? So it goes to track 0, uses the track 0 detector, and aha, here is track 0. Then it goes back to the track again that is trying to format. Now, couldn't format cylinder 79. Okay, so this is not the same problem that the person is having with his Amiga 1200. So yeah, I am going to try to restore this connection and then cut the connection for the gate signal instead. And I'm going to try to format the disk again and see what happens. I have now restored the connection for the incoming serial data, and I have instead cut the connection for the gate signal. So let's try to format the disk again and see what happens. You know, that last attempted format, that totally messed up the content on this disk. So what I did was to put extras back there again, using my other Amiga 1200. So let's try again here, and format this disk, and see what happens. Now remember, I have cut the other line here, so now the gate line, the gate signal is cut, and I have the incoming serial data restored. But the gate signal also has to do with the write operations, so I can still read the disk even though the gate signal is cut. No problems. So now let's format and see what happens here. Okay, format. And will you look at that? It looks like the disk is being formatted. The progress bar is moving just as it should, from left to right at normal speed, and it really looks like the disk is being formatted. And it's pretty much about to be done here. Now this is going to be really interesting. Let's see what happens. Alright, initializing. Let's see. Ha! Bingo! Extras, it didn't format the disk. There we got it. And can I still read it? Yep, the content is still there on the disk. It didn't write anything. It didn't format. So, my friend, you know what? You have a problem with a gate signal on your motherboard. Alright, so now let's see what we have learned so far. So, we know that you have a problem with the disk write enable signal, or the data write gate signal. And that is coming into pin 24 of the internal disk drive connector. And it's also going to pin 16 of the external disk drive connector. Now we also know that the problem with this signal must be located somewhere on the motherboard before it splits up to DFO and DF1, because you are having the same problem with both DFO and DF1, right? So what can be done in order to fix such a problem? So let's talk a little bit about that. Okay, now like I said, this was just a really rough diagram, so let me show you how things are actually connected on the motherboard. So here we have the internal disk drive connector, and we have the external one here. And pin 24 of the internal disk drive connector is connected to pin 16 of the external one. And that is going through a 27 ohms resistor on the motherboard, and that is going to a chip. And this chip is not part of one of the custom chips. This belongs to the 74 logic family. And in this chip we have four XOR gates, or exclusive OR gates, and it's called 74LS86. And there might be a problem with this chip, or there might be a break in the trace somewhere here on the motherboard, or there might be a problem with this resistor, so that this resistor is open, meaning that it's cut off, it's not there basically. So then, and of course if that's the case, the resistor has to be replaced, but that's not that difficult. In the case of that this IC is the problem, then it can be replaced, it cannot be replaced that easily. It's a little bit tricky, but it can be done. But it can be found really easily, because this is just a basic electronic component. So it's not like you have to find a new custom chip. This is just really basic component, so it can be easily be found, I think. So this is how things are actually connected on the board. Alright, what I would like you to do is take your multimeter, one of these guys, and if you don't have one, you should really buy one. You can just buy a cheap one, that will do just fine. So I want you to take your multimeter and put one of your probes at pin 24. And the way you count the pins is this. So we got pin 1 at the upper right, most upper right position, and pin 2 at the most lower right position. So it's like this: pin 1, pin 2, 3, 4, 5, 6, 7, 8, and so on. So pin 24 can be found at the bottom row here. And you can also count it like this. From left, at the bottom row here, from left you count to 6. So 1, 2, 3, 4, 5, 6, right there. That's pin 24. Okay. And I would like you to put the other probe right here at the middle pin here. So here we got this chip I was talking about. So the middle pin right there. I would like you to put your probe right there. And then you should get a reading of 27 ohms. If you don't get any reading at all, then it's either a break in the line somewhere or this resistor is open. Okay, so let me now show you what kind of readings you should get if everything is working properly. So I got my mirror right here, and I will set it to a resistance check right there. I could use the continuity check because I think this meter beeps under 30 ohms or something like that, but I will just use the resistance check here. So let me put that there, and let's see. Now of course if I put these probes together, I will get almost 0 ohms there. So let's count here: 1, 2, 3, 4, 5, 6, and there we got pin 24. And let's check this middle pin right here, and there we got 27.7. So about 27 ohms. And now if we check the resistor here, so now I'm checking the bottom, the lower side of this resistor. So we're getting 27.6. Okay. Then that means that if I check the upper side of the resistor, we're getting almost 0 there. So that means that this pin on this chip here must be connected to, let's see, yeah, it's connected to the bottom side of this resistor, and then it goes through the resistor to the upper side here of the resistor, and then it goes to the internal disk drive connector and the external disk drive connector as well. So you could just probe the resistor like this also if you want to, like this. And yeah, you can probe here on this chip. So you can easily find out if there is anything wrong with with this signal trace here, or if it's the resistor that has blown, or something like that. Now if you do get a reading of 27 ohms between pin 24 here and this pin here, then you could let me know in the comment section of this video. and I might make a follow-up video where I give you some further advice. But if you don't get any reading at all, then there might be a break in the trace on the motherboard, or there might be something wrong with this resistor. So you can just use your multimeter and find out. If there is a break in the trace, then you can jumper wire this point here. It's kind of small, but if you use a soldering iron with a really fine tip, then it's possible to do it, and use a really fine wire, not a thick wire. So you can jumper wire this point then to the bottom side here of the resistor. You cannot jumper wire it to the upper side, that's no good, because if you do that, then you need to put 27 ohms resistor in series on the wire. But it's better to just put it on the bottom side here, and if this resistor is the one that is causing this problem, then just replace it. So yeah, that's a few ideas. By the way, I don't know what the revision is of your motherboard, but the motherboard I have used to show you this is of revision 1D. Now I have another motherboard here of revision 1A, and it's pretty much the same. So if we take a look at it, we can see that we got our internal disk drive connector here, and we got this little resistor that we're interested in right there. I think it's this one. And here we have our IC, the one that I was talking about earlier. So yeah, I guess that's it. So if you have any questions, feel free to let me know. And I hope this video was useful to you, and I hope you will be able to fix your Amiga. So thanks for watching, and see you next time.